In this video we will be going through the conversion from denary to hexadecimal. Alright, now in order to convert from denary to hexadecimal, the first step is actually just going we are just going to convert from denary to binary, and from binary we can convert it into hexadecimal. Okay, so it's actually the process. This conversion has nothing new to it. We're just going to perform what we already know about denary to hexadecimal conversion, from denary to binary conversion, from binary to hexadecimal conversion. Okay, so let us actually take an example of denary to binary conversion that we have already performed. So this for example 213 conversion that we had over here, right? If you have not watched this video, this should be the really first video, so pause this video, go back and watch denary to binary conversion first before going through this video. All right, so this was the number 213. Let's say this is the number that we want to convert to the hexadecimal, right? And the first thing we do really is, as I have already specified, the first thing you do is denary to binary conversion. Okay, so I've given you 213 to convert it into hexadecimal, but the first thing you do is actually convert it into binary. So you find its binary representation. Once you have the binary representation of that, the next thing you need to do is take the binary representation and partition it into two groups of 4 bits. Okay, so this first group, and then this is the next group that we have. Okay, you take the two groups, okay, and you individually convert each one of them to hexadecimal. Okay, so we are this is step converting from binary to hexadecimal. Okay, so you take the first group, that's 1101, right, and then convert it into the hexadecimal. So in order to convert it into hexadecimal, now we have to write down again the powers of 2 separately for them. So 1 2 4 8, right? So 8 plus 4 is 12, 12 plus 1 is 13, 13. The hexadecimal representation for 13, well, actually let me first write down 13 over here. So the total of this is 13, and the hexadecimal representation for 13 is just D. Okay, so that's the representation for the left 4 bits. Now for the right 4 bits, we have 0 1 0 1. Again we would write down the powers of 2 over here. So the total of this is just 5, right? So I will write down 5 over here. And what was the hexadecimal equivalent of 5? That's just 5. I mean, we don't have a special symbol for 5, right? We don't have a letter for 5. Letters actually start from 10, right? So we will just write this down, D5, and that's our hexadecimal conversion, a hexadecimal equivalent of 213 that we had written over here. Okay, so the conversion of this is D5. All right.